Alright, next we want to look at finding nth roots, which basically means something larger than the square root or the cube root. So these basically work the same way. If we want the fourth root of 16, that means we want to know what times itself 4 times will give me 16. And that number is 2. So this is going to work like those other ones did. The reason we can do that is because, whoops, sorry, I'm about to skip ahead. Because 2 times 2 times 2 times 2 is 16, which is the same thing as 2 to the 4th is 16. So that's what allows me to say the fourth root of 2 to the 4th, because the index and the exponent are the same, they can cancel, and that leaves me with a 2. For the next one, the fifth root of 243, I want to know what times itself 5 times is 243. And if you put that into the calculator, it's going to come out and tell you that it's 3. The reason for that, of course, is because 3 times 3 times 3 times 3 times 3 is 243, which of course is the same as 3 to the 5th is 243. So that allows me to say the fifth root of 243, or 3 to the 5th. The index and exponent are the same, so they can cancel, and that leaves me with 3. Then for the next one, this one's asking me for the square root of negative 16. So remember, this is where we have to think. This one is a square root that is an even root. So there is nothing I can multiply times itself and get a negative number. So the answer to this one is not real. While number 4, the index for this one is odd, so we will be able to do this one. And you can reference back to problem 2 that we just did. We already know that the fifth root of 243 is 3. So I bet you can figure that the fifth root of negative 243 is going to be negative 3. And same reason, that's because negative 3 times itself 5 times is negative 243. Same thing as negative 3 to the 5th is equal to negative 243. So the fifth root of negative 3 to the 5th, we can cancel the index and exponent being the same, and it leaves me with negative 3. Alright, the next thing we're going to look at are rational exponents. And of course, you know this word rational from the last test. This is when the exponents are fractions. And actually, all the ones that we've already done, the exponents have been fractions, because you know that any integer over 1 is that integer. So every number can be written as a fraction. So we've actually already been doing this. We just didn't have to pay any attention to it or show it because it was just a 1. But if n is a positive integer that's greater than 1, the nth root of a is a real number, then a to the 1 over n is equal to the nth root of a. So this is saying a to the 1 over n this is going to be my exponent, and this is going to be my root. So you see how I got from here to here. I'm going to have the nth root of a to the first. Okay? Let's look at some examples. So the first one, 9 to the half. Remember, the top number in the fraction is the exponent and the bottom number is the root. That's always true. So we're going to rewrite this. It's going to be the square root, because it's a 2, right? So square root of 9, and the exponent is 1. So we don't have to write an exponent of 1. If you wanted to, you could do it like this, but you don't have to. And then we know that the square root of 9 is 3. So when the exponent is 1, these are going to be a lot simpler than the next ones that we look at where the exponent is not 1. So for number 2, my exponent is 1 again, my root is 3. So it's going to be the cubed root of 27. And again, if you want to write to the 1, you can, but that's not going to make any difference. And then we know the cube root of 27, the number we multiply times itself 3 times is 3. For the third one, we're not going to be able to get a value for an answer, right? Because we have a variable. So this is the exponent and root again. So it's going to be, the root is 2, that's a square root of x to the first, which is just square root of x. Now be really careful about the difference between 4 and 5 as we do these. And you look, see how similar they are. Remember, for number 4, when I don't have the grouping symbol, the parentheses, around the negative 16, this is the same thing as negative 1 times 16 to the half. So this one is negative 1 times. My root is going to be a 2, so it's square root of 16 to the first, which won't make any difference. So this is negative 1 times 4 is negative 4. For number 5, though, the 16 or negative 16 is enclosed in a parentheses. So this time when I rewrite it, I have a square root. The negative 16, the whole thing, is going to go under the radical. And then we've talked about before that if I have an even root of a negative number, that this is not real. Alright, for the next one, this one is kind of similar to 14, we just don't have the negative in there. But we can write this as 7 times y to the 1/4. So a lot of this is about what the base is and what has to go under the radical and what does not. So that's why it's important to know here that it's 7 times y to the 1/4, because the y is the only thing being raised to the 1/4. So we have a 4th root of y to the first, and again that exponent being 1 doesn't change anything, so this is just 7 4th root of y. Alright, the next one, of course, is probably the most difficult that we've done so far. I've got a parenthesis around the 16x to the 12th. So that means the whole thing is going under the radical. My root is a 2, so I'm looking at a square root. And that 16x to the 12th whole thing is going under. The exponent of 1 doesn't change anything. So this is where we can use the stuff that we were talking about earlier. I need to write 16 as a number raised to the second power. So I'm going to say 16 is 4 squared. And then x, we need a power to the second. So we need to know 2 times what gives me 12. And that's going to be 6. So then we can cancel the index and the exponents that are the same. And this leaves me with 4x to the 6. Alright, so the next couple that we're going to look at, the difference is now the exponent is not going to be 1. So it is going to make a difference in the problem. It's going to work the same way. The numerator is the exponent and the denominator is the root. So this first one can be rewritten as the cube root of 8. And now I'm going to say to the second power. So we know that the cube root of 8 is just 2 because 2 times itself 3 times is 8, right? So it's 2 to the second power, which is equal to 4. For the second one, the first thing we want to do again is write it as -1 times 16 to the 3/4. Then this is my exponent, and this is my root. So we have the 4th root of 16 raised to the 3rd power. So we know the 4th root of 16, we looked at that earlier. That is asking what number times itself 4 times is equal to 16. And that number is 2 raised to the 3rd still, right? So that's -1 times 2 to the 3rd is 8. So this answer is -8. Then the last one of these, this time my base, the -27, is contained in the grouping symbol or the parenthesis. So this time I have the cube root, the -27 goes underneath, and the whole thing is raised to the second power. So the cube root of -27, we want to know what times itself 3 times is -27, and that is -3. That's being raised to the second, but again the parenthesis is important because this one means -3 times -3, which is +9. Alright, the next couple are bringing back that exponent rule that we learned, that if we have something raised to a negative exponent, we can take its reciprocal to make the exponent positive. So when I see that my exponent is negative, I'm first just going to move that whole problem under a 1. And then my exponent is going to become positive. From here, we can work this now just like we did the others. I'm going to have 1 over. The root is 3, so it's the cube root of 8, and that whole thing squared. So this is going to be 1 over. The cube root of 8 is 2, and we need to square that. So the answer is 1/4. Then for the second one, same idea. When the exponent is negative, the first thing I'm going to do is rewrite my problem. Now the only thing that this affects is the exponent. So the negative 27 is still negative 27, but the exponent will become positive. So we can write this as 1 over. The root is 3, so it's cube root. The negative 27 is in a parenthesis, so the negative 27 is going to go underneath, and it's raised to the second power. So the cube root of negative 27 is negative 3, and we're going to square that. So that's 1 over negative 3 times itself is 9. Alright, these last couple of problems are still using what we've learned, but it's kind of going in the opposite direction now. You remember, if I had something to a power like this, this was the exponent, this was the root, and this is the base, right? So now this problem is given as a radical, so I'm going to rewrite it as an exponential so I can see if I can reduce it. So the base is x, and the exponent is going to be the exponent on the number divided by the root, right? So here the exponent is 3 and the root is 6. And then from here, I can simplify 3 over 6, right? That is 1 over 2, dividing the numerator and denominator by 3. And now we can turn it back into a radical, knowing that the bottom number is my root. So I have the square root of x to the first power, which we don't have to do anything with. All right, one more. So this time I have 2 things under my radical. So my bases are a and d. When I rewrite, we know that this is the exponent and this is the root, and the exponent goes on top. So it's going to be a to the 2 over the root 4, d to the 6 over the root 4. And then we can simplify. 2 over 4 is the same as 1/2. And d to the 6 over 4 is the same as 3/2. So then to rewrite it as a radical, you notice that both of the denominators are 2, right? denominator of fraction exponent is 2. So that means we're going to have a square root. And then the top numbers are the exponents that will go with the variable, right? So it's going to be a to the first, d to the third, which of course we can write as square root a d to the third. Now, trust me, I understand that these rules are probably something new and different, and they do look a little difficult to begin with, so they will take some practice most likely to get down. But hang in there, and if you have any questions, make sure you let me know.